Oops. Hi everybody, welcome to the garden and to today's Science on Sundays talk. We have Nadia, a research associate at the Sainsbury Lab, which is based on site, here to talk to us about the amazing properties of broad beans. So I'm really looking forward to this talk. I hope you enjoy it, and please do fill in a feedback form at the end of the talk before you leave. Over to you, Nadia.
Thank you, Rafi. Hi everyone, I'm Nadia, and as Rafi had mentioned, I'm a research associate at the Sainsbury Lab here located at Botanic Garden, and I'm also college research associate at the King's College, Cambridge, and the Entrepreneurship Lab. Now I am pretty much a legume biologist. Legume, or the bean family, is something that I'm very passionate about. And today I'm going to talk about broad bean and the project, pretty much the broad in mind, and how broad bean can be used to improve our mental health and also our planetary health. So just an overview of the talk. First, I would like to present to you the historical account of how broad bean was domesticated from the Fertile Crescent to Britain. And then I'd like to explain how broad bean is very important for agricultural sustainability, specifically for nitrogen fixation and also pollination by very specific bees. The next one is how broad bean can be used as functional food, specifically for better mental health. And this is because of the fibers, the L-dopa and GABA. And how we should be able to improve the bean through plant biotechnology. Okay, so the scientific name of broad bean is Vicia fava. And there are many names to this bean. Usually in the UK, we call them as broad bean, and it refers to the fresh bean. Fava bean is usually used in the US, the Americas, and in the UK, we actually use it for the dried version of it. So there are two major subtypes. So Vicia fava var major, they are bigger seeds, and the var minor is the smaller seeds. And in the UK, we call the smaller seeds as horse beans or field beans. Currently, this is the biggest legume crop that is grown in the UK. But we don't really exactly retain this in the country. They're usually exported to Egypt to make falafel or fed to the animals, not exactly being consumed by us. So, as I mentioned, the scientific name is Vicia fava. So this particular bean is actually in the same family as vetches, but they don't look like vetches. And this is because it has been domesticated by humans for centuries. And it is first domesticated in the Fertile Crescent in the Middle East, this particular region here. And in Britain, we know that it has been consumed here since the Neolithic age, becoming more popular in the Middle Bronze Age to the Iron Age. So means that this bean has been cultivated and consumed for thousands and thousands of years in Britain. And because of that, we have the right and the good bacteria for the beans that I'll explain more about. So another name for this bean is called Celtic bean. And this is primarily used by the archaeologists because they are first found in Celtic archaeological sites, especially during the Neolithic era. So over here is the sites that we can find the Celtic beans, or we have found the Celtic beans during the Iron Ages, the settlements during the Iron Age. And actually, if we look here, number 75, this is actually the closest site to Cambridge. So it's at the Estonia camp at March, and it's actually the lowest hill fort for Roman, as a Roman camp in Britain. And so how we actually know that they were consuming this particular bean in this site is because we can find the charred remnants of the beans. So the Romans very likely either accidentally spilled the beans into the fire and then got charred, or someone burned them. And so because they are pretty much charcoal, nothing can degrade it. And that's how, because of that, it actually remained in those sites. And we actually found the remnants of these beans, meaning that it has been consumed since the Iron Ages, specifically in this particular area here in close to Cambridge, and has been consumed since then. Another name for this bean is horse bean. Particularly during the 1590s to 1800s, this bean was made into horse breads and fed to the horses. And so there is this one fabulous article by William Rubble, and he did an extensive research on English horse bread and how this bean was used to make this horse bread and fed to the horses. So this is the first horse bread recipe from the 1593. Says take a strike of beans, 2 pecks of wheat, 1 peck of rye, grind this together, sieve them and knead them with water and balm. So this is the frothy mix of the beer. And so bake them thoroughly in great loaves as a peck in a loaf. And after they are a day old at the least, your horse may feed on them, but not before. So it needs to be left at least 1 day before you feed to the horses. And this horse bread was actually made into food for the peasants too during the famine. And because of this, the elite aristocrats wouldn't eat this type of bread because it is associated with the peasants. But now we know that bread with beans are actually good for you because of the protein. Talking about protein, broad bean is a very reliable source of sustainable protein. And so when we talk about protein, nitrogen is the essential element that pretty much provides a building block for making the protein. And this is why we actually use nitrogen fertilizers to grow our crops. We know this, how important this is during the Green Revolution, where there's a high use of nitrogen fertilizers and actually increase the global crop productivity. However, synthetic nitrogen fertilizers use a lot of fossil fuels, and it also increase nitrous oxide, which is a very potent greenhouse gas. It's way more potent than carbon dioxide. So why are we using fossil fuels to actually make nitrogen fertilizer? It's not that the fossil fuels is being turned into nitrogen fertilizer. We actually use it to increase the temperature and also the pressure. So then we can use the nitrogen from the air, break it down, and then make it into ammonium. And this is why the nitrogen fertilizer price always follows the price of fossil fuels. And currently, because of the geopolitical tension in Strait of Hormuz, we know that nitrogen fertilizer is very, very expensive for farmers. Currently, before conflict, it's about $100+ per ton. Now it has become 5 to 6 times more. So now it's quite challenging for farmers to grow their crops productively. So what is the alternative? It's biological nitrogen fixation. And specifically, biological nitrogen fixation with legume crops, or the bean family. And this is facilitated by specific bacteria in the soil called rhizobia. And this association can fix nitrogen from the air at ambient temperature. There's no need of high temperature, high pressure. And this is because of the presence of this particular enzyme called nitrogenase. So how does this work? A lot of the time, the majority of legume species can fix nitrogen if the soil has the specific bacteria that can actually associate with. And once they found the right bacteria, the plant roots, the legume roots, can form these structures here called nitrogen fixing nodules. You can see here an example on soybean roots. This is on clover root, and it's very, very tiny. And I hope you can appreciate that when you open this, cracked open this nodule, it's quite red. And this is because there's a presence of a pigment or protein called hemoglobin. It's legume hemoglobin. And it's actually quite similar to the hemoglobin in our blood that makes it red. So that's why it's red. And if you want to know the nodules are fixing nitrogen or not, crack it open. If it's red, then the nodules are fixing nitrogen. And so pretty much, if you have the right bacteria in the soil, growing the legumes, they're forming these nodules, pretty much we do not need nitrogen fertilizers because they're already fixing nitrogen for the plant. So that's one, I would say, angle of why broad bean is important to the soil, which is to improve nitrogen levels in the soil. The other part is broad bean also provides the ecosystem service by providing nectars to the pollinators. So these are actually 3 different bees. Obviously, this one are doing the same thing, which is pollinating the flowers. But these 2 are actually doing something slightly different. So this is a honeybee, this is a short-tongued bumblebee, and this is a long-tongued bumblebee. These 2 bees are actually stealing the nectars by actually going to the back of the flower here and actually stealing it. So you can see here, it's actually not coming from the front. So the best pollinator among these 3 is actually this one, it's the long-tongued bumblebee, because this one has long enough tongue to actually get to the nectar, which is at the base of the flower, which is the tube, or call it the corolla. And usually when these bees have shorter tongue, they couldn't actually reach the nectar. That's why they start stealing the nectars. And because of this, if they're stealing the nectars, they're not exactly pollinating the flowers properly. So the best pollinator is actually this one, the long-tongued bumblebee. However, at the moment, the population is declining. So one way or another, if we grow more broad beans, we're also helping this little guy to survive. And as you can see from the previous picture, the most common type or variety of broad bean is the white flower ones with speckled or spotted purple patches on the flower. And that is the most common one, but we actually have diverse varieties of broad beans that have a range of colors. Some of them are a little bit yellowish, a little bit pinkish. Some of them are completely purple. And this would also change how these flowers are actually attracting the different pollinators too. And we also have a diverse range of the colors of the seeds, even though primarily the ones that we consume here or we grow here in the UK are usually somewhat this color, like brownish color, but some of them would have this spiral pattern on the seeds. Some of them are a little bit purplish, some of them a little bit pinkish. So there's a variety of colors of both the seeds and also the flowers. And amongst all of this, I would like to focus on a particular variety of broad bean called martok bean. And you can see from this picture here, the seeds are pretty much, they are not one size. They have a range of sizes and slightly different colors. And this is one of the oldest recorded vegetable variety from the 12th century. And it is named Martock bean because it originated from the village of Martock in Somerset. And you can still buy them. They're still very, very good source of protein. Okay, so now, why does broad bean good for mental health? First reason is that it is a pulse. It's considered as pulses, and pulses are high in fiber. Now, because of this, the fiber that we consume can be fermented by our gut bacteria, and this can produce short-chain fatty acid that would stimulate the production of neurotransmitter. And we know that there is this gut-brain axis where having good, healthy gut microbiome could also influence your mood because of this neurotransmitter production. So if you consume more fiber-based food, like pulses, including broad bean, then this cycle would also be improved. The next one is, and this is uniquely a property of just broad bean, not any other beans, but primarily broad bean. It is the production of L-dopa. So L-dopa is made from tyrosine. It's an amino acid, and it is also a precursor to dopamine, the happy molecule of the brain. And interestingly, L-dopa was first isolated from broad bean. So L-dopa is currently used as a drug. It's usually used in treatments for Alzheimer's and Parkinson's diseases. And recently, it has been shown that L-dopa can eliminate anhedonia in depression patients, specifically depression that is due to brain inflammation. So anhedonia is a symptom where the patients cannot experience joy and happiness. And by consuming L-dopa in their diet, they could start feeling happy back again. And there's also a known food supplement from broad bean that contains L-dopa, very likely in a complex. And this has been shown to have neuroprotective effects on the neurons of the brain. And this is uniquely in broad bean, only in broad bean and not any other beans. The third one is that if you ferment broad bean, it can also increase another neurotransmitter called GABA. So fermented beans, they allow the good bacteria they use for the fermentation to use glutamate, which is another amino acid, and turn it into GABA. And if the fermentation is done in very specific conditions, the beans themselves could actually make GABA. And GABA is a neurotransmitter that is known to reduce anxiety, and it's associated with relaxation. So some of the food, fermented food, is doubanjiang, which is it's a fermented chili bean paste. There's also, I would say, miso umami paste made by broad bean, and also tempeh, which is another fermented food product from broad bean. And I think one thing that I would like to emphasize here is that I know that the easiest way to prepare broad bean is just blanch it in water, but it is a very versatile ingredient. You can make a lot of different food from it. So one is that we have broad bean flour, and we can use this to make bread, as I mentioned, the horse bread. We can use it for making pancakes, brownies. And we also can actually smash the beans into, I would say, spread on toast, and also pesto. Can make into tofu. So specifically, if you make tofu from broad beans, they're very firm. If you like firm tofu, I would suggest you to use broad bean instead of soy. Can also make to pudding. And also the young shoot is also edible. Then you can make it into salad. Now, however, I would like to give you a warning. Do not eat this bean if you have favism. So what is favism? Favism is it's a genetic, I would say, mutation. It's a natural genetic mutation in very small number of human population. And it is associated with this G6PD deficiency. It's an enzyme. So G6PD is an enzyme. And usually people who has this deficiency, they would not have any symptoms until it is triggered. So once triggered, it will actually induce this hemolytic anemia. So this cartoon actually showed that X-linked recessive disorder characterized by red blood cell hemolysis, meaning that it bursts, the red blood cell bursts, after exposure to oxidative drugs. And this includes aspirin and fava beans or infection. However, particularly for broad beans or fava beans, we know what kind of chemicals are the culprit that actually induce this particular reaction in people who have G6PD deficiency. And these are the two chemicals called vicin and convicin. And now with genomic technology, we actually know how this broad bean actually makes them. So the biosynthesis pathway of how these chemicals were made. There's also another issue about beans in general, which are the anti-nutritional compounds. And this is the one that contribute to the gas issues. And primarily, this is because compared to soy, broad bean has not been extensively bred, meaning that they still retain this nutritional compounds. And this would lead to bloating and sometimes affects nutrient absorption. So this is why we actually need to improve broad beans, and we need to accelerate the improvements. There are so many good things in broad beans that we could actually improve them and increase them. And also the not so good ones, we could actually reduce them. So how can we do this and do this faster? And this is through plant biotechnology. So if we are relying on just classical breeding, this is very slow and very tedious. An example of classical breeding that has domesticated a particular crop is how modern corn was domesticated from a very ancient hyacinthe. So you can see here, there's barely any cob that like grains, right? And so this took 1,500 years to get from this to this. And with new genomic technologies, we can domesticate crops way faster. So this is an example of a wild rice that is somewhat very similar to teosinte, not a lot of grains, barely edible, I would say, but only within a few years, they could actually domesticate it into something that pretty much a crop that can be harvested and also edible. So with that, we can have improved beans that have more of the good things, the fibers, the L-dopa, and we can reduce and eliminate the bad things, especially the vicin and convicin, so more people can actually consume it safely. So another thing that I would like to highlight about the high L-dopa, because this is uniquely it's a unique property of broad bean, is that it can reduce insect pests. What we know of is that if broad bean is infested by aphid, it would actually produce more of the L-dopa that could attract pretty much another insect that could get rid of the aphids. And it also can reduce weeds. So L-dopa, even though it's neurotransmitter, it can make the neurotransmitter in our body. It is actually an allelopathic molecule. So allelopathy means that it's a chemical where the plant is using to suppress the growth of other plants. And because of that, it can be used to reduce weeds. And obviously, as I mentioned, it's a legume, so it can fix nitrogen. So if we grow more of this bean, we can reduce pesticides and also the usage of synthetic nitrogen fertilizer. And why, especially the nitrogen part, why is this very important? Is that this is currently the state of our planet. We currently have exceeded the safe operating limits for planetary boundary. This particular picture here is a satellite image of Lake Sinclair. And this particular region is bordered by Canadian farmlands. Because of the runoff of nitrogen fertilizers from these farmlands, it actually makes this swirl of green things, and it's actually alga bloom. And this would pretty much suffocate the aquatic life in this lake. And what I mean by planetary boundary is that there are a couple of properties that we need to be monitoring for a safe planet. One of this is nitrogen usage over here. As you can see, we already exceeded the safe operating limit, and we're in the territory that we just don't know what kind of consequences it will have to our ecosystem. So we need to have more of improved beans, improved legumes, and you cannot wait for another decade to see what will happen to our planet. So I hope that I've convinced you to eat more beans. So broad bean is a British bean with very long history. It has been here for centuries. And actually, UK is the ideal weather to grow more of this bean. It's very good for mental health because of the fibers, the L-dopa and GABA. And for planetary health, it can provide food for pollinators, especially the long-tongue bumblebee that is currently dwindling, can reduce pesticide usage and also reduce synthetic nitrogen fertilizers. And this is a plug for the systematic bed here at the Cambridge Botanic Garden. Specifically, there is a legume bed. If you're thinking of looking at more beans, there's a specific legume bed. They don't have the broad bean there, but you can see like a lot more legumes there that most of them can fix nitrogen. And thank you.